Welcome to part 2 of training of OpenTunnel. We will import the soil, so press import and read the IFC file. We select the different layers that we want to import by pushing them to this right side of the window, and the soil I imported. If we fit the design file, we can find these different layers by different colors. And all this in 3D triangles. We can now define the geometry for the tunnel. Let's display a top view, and we will place an horizontal alignment, simple horizontal alignment, so through complex by API. Giving a name, so standard name, and define the first PI at the left of the terrain and push a line crossing all the terrain. So simple one. Second PI, reset to save the alignment. Now we select the alignment and we will open a profile window. So we open this window on window 2 and we display this profile. We will ask for cutted elements on full profile. This will take a little long because of all the triangles crossed by this alignment. And we can see the terrain that appears with the different layers. All this is exaggerated by a ratio of 10 as the default value. We build, so we change the ratio by 2 and extend the window. It's easier to place our profile. You can place it at whatever ratio you want. Now we take the complex geometry profile, complex geometry profile by API. Okay, and we place a profile that goes from left to right with a slope at the beginning. So it's a small curve. The curve length is 120 meters, excuse me, and approximately in the middle of the layer. So you are sure that the tunnel doesn't get out of it. And in here is following the the limit between the two layers. That's the ideal position. So we activate this profile. So now we have a 3D definitions. So we will place a tunnel corridor. And don't forget to put it as conventional, as we will place a conventional one here. Once it is placed, we can place the start point for the tunnel. So being first line and the end point for the tunnel after the terrain, so we can see the tunnel getting out of the ground. Now we will define the template. So for the template, in fact, the templates are attached to the design file. So we just import this template from the library that we have created. So we import myconv that we have defined in the first training part. This is our template, and we will update the different parameters. So 8 to 4, width to 8, wall thickness to 0.5, and the other parameters 2.5 also. Then the lower parameters, so from the lower part, bottom line, lining thickness 0.5, and the edge width and depth 2.52. So now we have updated our template to the new definition. But you can see that there is a problem. We have a problem now with this version, is that the lining definition, which is defined by region, the region are not associative with the different elements. So we will delete, in fact, all the reinforcement and redefine. So for some part, we have attached them to the parametric definition, but for the other one, no. So here we will redefine the lining. So define, we know how to do from the first part of the training. So select the left, press control and select the right, then accept, and do the same for the other parts. So here, don't forget the small part at the top here and accept. Do the same on the other side. Here and accept. Then do the both bottom side here, and also here and here. You can eventually remove the level where you have the construction lines, so you don't have this problem with adding with control key the different parts. So once it is defined, save changes, we check, yes, we have 1, 2, 3, 4, 5, 6. Okay, and we can define the materials. So define type of concrete for all, C2530. This is just for the quantity, and eventually when you send to Praxis. Okay, here we have defined all, and we can close. So we will be able to place the tunnel. So place tunnel here. Locate first reference line. So we click on the reference line and accept. Check the parameters. The section length is 5 meters. That means that we will model 5 meters by 5 meters. We can define also with offset and different things. And last offset, reference line for the end of the project, and the software will create the tunnel. And we can see the tunnel, so from the left part and the right part. So if we get around here, you can see the tunnel inside the ground. We can zoom in. We can change the display. Okay, I'll define a smooth modeling or okay. Okay, if you can see in the Explorer data, so you have the different part of the tunnel, so we can turn on and off the different parts. And for instance, if you turn off the lining, we see only the excavation. And if we turn out the excavation, so there can be several excavations, so we have to get under. And you can see that maybe it's not so clear here with the view that we have, but yes, we can see the axis going in. So all the soil has been removed all along the excavation. Okay, we can see a little like that. Okay. So we can continue now. We will put on the lining because each time we will place reinforcement, it will ask to show the tunnel, to point to the tunnel. So we need to place the different things. And we can eventually put on excavation too. Now, let's see what happens on the profile. So here we have our profile view, okay, where we can rearrange different things. For instance, going back to an exaggeration of 2, as it was, okay, fit the view, and we can now update the crossed element. So this will take time, so it will remove all the display of the crossed elements, and we'll recompute crossing the different elements. And we can check here exactly, so you find everything. So you see the ground has been removed, and we can see the lining, which is filled, and the hole that we have between the lining and the excavation. Now let's define some reinforcement. So we will delete the existing reinforcement that we put in our template in the library because simply it was not associated. We could have put it associated with a different change. As I said, the only problem is mainly with the regions that are not correct. And we can remove now different elements by removing in the display list the different levels, so we can define the theoretical excavation that we define inside this cross-section. As I said, the lines defining the excavations are associated, but the regions are not, so that's why they have totally disappeared, because my cross-section didn't find anything. So we define the different excavation. So associating the two upper parts. In the first one, at the bottom, the first one with a small slice of ground here, and the one on the side. Okay, but you see we have forgot just one part of it. So it's very difficult to redefine. So the only way is to delete them. So we will discard changes and restart. When you made an error, it's very simple to define. So don't need to try to rearrange. Let's do again what we have done because we discard changes. So everything has been kept. Do it again from the start. Okay, and display the different level. We know how to do it very quickly. Lining, through those, all that. Okay, and define the part. So part 1 on the top. Part 2, without forgetting the two different spacing here, and accept it outside. And finally, the third part here, and accept it. Now we can save changes. So we can see the three parts here. Just have to assign some materials for the quantity. So we assign two different materials from the top and bottom part and press OK. And we go back now in our top view and place the excavation subspace. So just by showing the tunnel and data point to continue, it will compute the subspace. So the subspace is not detailed as a solid. I mean, all three subspaces are on the same solid inside and fill, so it's exactly the same as the excavation. You don't have different things between subspace and theoretical excavation. So the only way to see that this has already been done is to make a report, a quantity report on the subspace. So in reinforcement, we have an excavation subspace, which is here. So if I go to report, if I go to quantity report and ask for the report for the tunnel, it just disappears in the background. So let's go back to that view and submit for the active tunnel. And you can see that in the excavation, so you have the three subspace, default 1, default 2, and 3, with the different type of soil that we have and the cubic meters by section. And we can continue now to place our different reinforcements, define and place, as we have seen, because we need to redefine them at the time of placement also. So here we will undisplay unnecessary things. So in a reinforcement, we will undisplay the excavation subspace. Okay, good. And now we will define reinforcement. So the different type of reinforcement. So the next one is jet grouting. Okay, so jet grouting. In jet grouting, you have two different type of jet grouting that you can do. We can do jet grouting on the crown and floor, so that means all around the excavation. So the soil will be harder and will stand by itself all around this. So we define the diameter of the jet grout. We define different positions, so center line offset, column lengths, and number of columns. In fact, before I put a center line distance to find out the proper number, and from then I find we have to put 43, and with 43, this I can see the jet grouting. So you see, I could put it a little more space between the different jet grouts because it's not necessary to have this so tight. So once it's defined, the same, define which prefix, and I select the tunnel and place it. And it will automatically place this column of jet grouting, 5 meters, which corresponds to each section that I've put. So we can think that we will work 5 meters by 5 meters, assigning the different jet grouting. And you can see the different jet grout cylinder, so all around the excavation. I can remove them from display, and now I can define the second type of jet grouting that I need to place, which is the front tail. So the front tail, it's a little different. It's when you have soft ground before, so to have the ground which is harder. So we in the front of the tunnel, we will jet grout also with a matrix. So we define the horizontal spacing, then the vertical spacing, minimum clearance from the side of the excavation, and the column diameter. So we put minimum horizontal spacing of 5 centimeters, the same in vertical, a minimum clearance from the side of 0.3. The column length will be 5 again. And the column diameter, we take the same as we had before, 1 meter, and we generate, so change the material and define material as jet grouting and generate the jet grouting. So we can see here the different circle, we save, and in the same way we can place it. So jet grouting, front tail, select the tunnel, and accept it. And we can see this different cylinder. So, okay, that represent the jet grouting section by section. Okay. By the way, you see that there was something missing. There was a hole. Yes, this hole. So here we will see that we really have a dynamic association between the template and our tunnel. So I noticed that I forgot, and I can see the blue square on the right bottom of the world, which is missing from the lining. So my lining definition is wrong. I missed a part of it. So I will redefine it. So to redefine it, first, I will remove unnecessary from the display unnecessary levels. So these are my levels. So I will remove the excavation and keep the lining parts. So as I say, the best is to delete them, to redefine. So I select, delete. So can delete by the key or by pressing the X, it's the same. Here I can see that it's not complete because I forgot I didn't see there was a line at the bottom. Here there is not. I delete this one. I delete this one. I delete this one. And I delete this one. And now I can redefine lining parts. So give a prefix, len, and start again tagging the element and defining the region. Okay, so select top, crown, boss, and accept. Select left and the small part here, and I accept it. Now, be careful on the right part not to forget any parts. So top part, middle part, and bottom part, and accept. Then after it's easy, this one, okay, and this one on the right, okay, and the three different parts defining the bottom one from the region, and I accept it. Okay, now everything is filled, so it's okay. I can save change. Okay, I can assign material. Okay, so I assign again concrete C2530. And close. And notice, as soon as I close now, the software is updating the lining for tunnel because it recompute. You notice that we have changed the lining definition. So it will recompute the lining, and now we have full lining in the tunnel. So perfect, we have a dynamic association between the template. So the template which is stored in the file and not the template from the catalog. So if we continue now, we will define shotcrete. So shotcrete is just also some reinforcement that we can place locally. Here we will define the shotcrete, for instance, just like that, as the space between the theoretical excavation and the lining part. So it can be a permanent wall as an area or just define a line of shotcrete because the shotcrete can be very thin. So here it's a full area, so we define this full area and we save it. And from that, once it is saved, I didn't put the right name, so I delete this and put the right prefix, shot. Change, forget to change, not to delete tag, but tag element. Tag element, yes. So this one, control the second one and accept this. It will be tied as shot and the number. And save changes. And the same, now we can, we have this shotcrete definition, which is placed. We can define the material. It's shotcrete. Press OK. And we can now, in the construction, place shotcrete as a permanent wall. We have seen, and assign it to the tunnel. Okay. The same, once it is placed, we can see it. We will remove it from display, otherwise we don't see anything. So here, excuse me, I show all the different type of reinforcement that we can place. Just note that usually we don't place all the reinforcement into the same cross section. Okay, so here I will go to the next one, which is 4 poles. So 4 poles still the same. So it's something to have the soil which is harder, but a different way to doing it is from the side we have kind of column that we place, but with an angle from the surface of the excavation. So it gets out of the excavation into the soil, but will go not parallel like we have like we have jet grouts, but it will be skewed. Anyway, you will see when we place it. So we have placed this circle same with the different parameters and place the 4 poles. So we can see, you see the driving angle is 20 degrees. So that means that the 4 pole will go at 20 degrees skew from the surface of the tunnel here. Okay. And I will place it showing the tunnel. So a part of the tunnel of the lining. And it will place this and you can see, so the same, we place it 5 meters after 5 meters, and you can see this serial of beams getting out of the tunnel and making the harder. The soil harder. Another type of hardening the ground is to put fiberglass. So this is in the front part of the tunnel where we push fiberglass small column. Also, still the same thing to make the soil harder. So after we can excavate without the soil to pour by itself. So we generate a matrix of this fiberglass, save it, and we can place them. So here again, I will remove the display of the 4 poles, okay, and put the fiberglass show the tunnel and place it. And we can see all of this fiberglass column inside the tunnel. Finally, we will place the last type of reinforcement, which is rock bolt. So you remember that we have defined them in the template, but we have to redefine them because they were not associated to the geometry, final geometry. So now we go in the template, reinforcement, and we define rock bolts. So you remember the way to define the rock bolt. So we have the excavation, which is displayed here, and we will place a line representing a bolt. So we place this line at the top of the tunnel, this one. So we snap to the intersection. Okay, and place a line at 90 degrees and with a length of 3 meters. Okay, and this bolt, we will copy it all around the circular part. So for that, we will take a rotate copy. So rotate copy, the active angle will be 15 degrees. And we make 5 copies. So 5 copies on the left, select the bolt, and we will snap to the center of the circle. Okay, so just go on the circle and snap. Here, and accept. And it places the different bolts around the circle. Then we have just to mirror copy the different bolts. And make a mirror copy vertical on the other side. Here. Okay, now it's drawn. So the only thing that we have to do is to define the rock bolt, so to tag the different elements. So we unselect this, okay, and we tag the rock bolts. Okay, so a group name is top, prefix RB, the beam diameter, which is the diameter of the bolt, so 5 centimeters, which is quite large, and the template, so the element will change color. This is the big advantage to have a template, so everything is defined in the proper definition. And we select next, so showing one after the other with a reset when it's complete. So we define, show the rock bolts. Okay, reset, and now accept. Don't forget to data point to accept. And you see now the rock bolts have changed their symbology because they use the rock bolt template. So we can save. And when we can save it, we can see in the template that they are placed here. Just have to define the materials and save it. And then we can place it. So we can define a number of rows by section. What is the start of set and the end of set? And it will place a series of rock bolts all along the tunnel. Here we can see the rock bolts. Now let's continue with the details. So we can put auxiliaries. So how to define auxiliaries? So we have two types of auxiliaries. We can extrude a profile. This is the first that we will use, or we can attach cell, which is the second type. So for extruding, so we will define a profile. So the easiest way, we will remove all the different levels of all the reinforcements. So you see there's many because we have defined all type of reinforcement. That's why there's so much. Okay. So we keep the lining definition and remove all this. Okay. Okay, so now let's define this. So we will create a small barrier very easily. For instance, so we use a shape, and we place a shape which is represent the side of the barrier. For instance, here, quite thin, and on top of this we had a handrail represented by a circle. Okay, and we will associate these two elements into a region, so by union. Okay, so by union, and we show both elements, and we accept the union of the elements. So this is the element. We will copy this on the other side. Okay, and we will tag the element as extrusion. So we tag the first one, barrier, B, and the second barrier on the other side, B. Good. So now we can save. We can save the change, and we can see in the template that we see 1 and 2, so the two barriers that have been defined. Okay, and we can set a material for stainless steel wire mesh for these barriers. Now, how to place them? So we will remove the display window, okay, and remove some of the reinforcement that we see, unnecessary display. So we have removed all reinforcement, and now I place auxiliaries. So place by extrusion. I select the one I want to place. So here I will place both at the same time, and again place locate tunnel here. And we can see these barriers, so with a nice pattern on top of it, all along the tunnel, inside the tunnel. So the second type of extrusion is to place extrusion placed by pass. So for that, the only thing we need is to define some cells representing what we are placing. Okay. So just define it in the window, auxiliaries. So define. So the same, we remove all the levels. We know how to do this. I could have done it when I have defined the auxiliaries by extrusion. Level display. So remove all these unnecessary things. Okay, and I will place it. So for that, I need to place a point. So I will place a circle. Doesn't matter the size of the circle. It's just representing the center of the circle, which will be the attach point. So for instance, I will place it here and put it a little lower under. So it depends how your cell is defined and what is the attachment point of the cell. So here I place a circle, not too big also, and just move this circle a little. Okay. Approximately here. Okay. And what is important is to tag this element. So it tags this element as a point, give the name of aero, because we will put aero machine at the top of the tunnel here, and save it. And the same, so in the template, you see it. And I place it, so I define which cell I want to place. So here you have, for instance, a fan, okay? That smoke fan that will be placed every 25 meters along the tunnel. For instance, I place them by distance. I can place them also by number, and be in the top view. I look at the tunnel where I place it. Okay. Which one? There is only one, so I select it. Okay. And it will prompt me for the start. Where is the first element I place, auxiliary element I place? Where is the last one? Okay. And how many do I place between these two limits? So every 25 meters. And now I just have, so the most complex things is to see them because it's very small things inside. So I will change the display in transparent. Yes, we can see it here at the top. Yes, by zooming in, so we can see the different things here that here, okay, placed every 25 meters, which are the fans. So the last thing that we will see now is we have the possibility to do a quantities report as we have placed everything. So just submit. You cannot change the format. The only thing that you can do is save it under Excel if you want to change this format, or you can directly print it. Thank you.